Alright, so let's introduce kind of our first chemical sort of topic, density. So, we'll talk more about the difference between intensive and extensive properties, but density is an example of an intensive property of a substance, of a chemical, whatever, which means it's not dependent on how much you have. It's the same regardless of having 100 milliliters or 5,000 milliliters or 300 grams or 1,200 kilograms. The density stays the same for that particular substance. Okay? Whereas like an extensive property is dependent on how much matter you have. Like say mass. The more you have, the more mass you have. Or volume. The more you have, the more volume it takes up. Okay? So, intensive properties stays the same for the substance regardless of how much you have. Extensive changes based on how much you have. Okay? So, density is defined as a comparison of how much matter there is in a certain amount of space. Okay? So I want you to think about those words. How do we measure matter? How much matter we have? And then think about how we measure how much space we have. Okay? And I'm hoping that you are thinking that really it's a comparison. Matter is measured as mass, okay, and then space is measured as volume. Okay, so really it's a comparison of how much mass there is per volume. Alright, so just to kind of think about that, based on the pictures below, which one appears more dense? Alright, we have the same amount of space, but one of them has more people or more matter. Right? So, should be saying that picture is the one that's more dense. Same amount of space, but there's more stuff in there, there's more matter in there, so it has more density. How about this time? Alright, this time we have the same matter, or same mass, but different volumes. Or different space. Okay, so even though it has less volume, because it has the same amount of matter, this technically is more dense, because you can see the people, the molecules, the matter, are closer together. So, there is a relationship between volume and density. Okay, so these are some common substances, things that we may use. You can see this is kind of visually showing you that based on the same amount of mass, okay, we're all considering this to be 10 grams, all right? 10 grams exists in more volume for lithium, and then the volume decreases as you go down. So as you go down, density increases. Because we're squeezing 10 grams into smaller and smaller spaces. Okay? Okay, so density is what we call a derived unit, or it comes from the combination of two base units. Okay? Really, it comes from an equation. Alright, density can be calculated by taking your mass and putting it over your volume, or mass divided by volume. Alright, these are probably the common units for density that you'll see, grams per milliliter, grams per centimeter cubed. Alright, but any variation of a measurement of mass over a measurement of volume is an appropriate unit for density. So if you're working with huge things, you might do kilograms per liter. If you're working with really, really tiny things, you might do milligrams per, and go even smaller than milliliter, microgram, or microliter, or something like that. Okay? But think about why all of these examples are units for density. Well, how do we measure mass? Base unit for that is grams. Okay? And then volume, if it's a liquid, we'll measure it in some variation of liters. If it's a solid, we'll measure it in some variation of meters cubed. Okay? Because solids you actually physically measure and find volume, whereas liquids you have to use like a graduated cylinder or a beaker to measure their volume. Okay? Alright, so a couple of different ways to think about rearranging the equation to solve for any of the variables. I could give you density and ask you for mass. Alright, or I could give you, density and mass and ask you for volume. Alright, so D equals M over V is not the only way to utilize the density equation. So, on the right side, this is a fun little triangle that makes it very visual for some people. And you have to think about if we're solving for, say, density. Alright, so if you kind of cover up the D with your finger or something, it looks like you have mass over volume. Okay? Or if we want to solve for volume, and you kind of cover up the volume, it looks like you have mass over density. And then last thing, if you have mass and you cover that up, these are both next to each other, so it's density times volume. So if you like the triangle method, go that way. I also, sometimes you just prefer the actual math behind it. Alright, so if we start with our equation density equals mass times volume, say we want to solve for mass. You want to move volume to the other side, so you multiply both sides by volume. Okay, and that'll give you this. Now, if you want to solve for volume, the trick is volume's in the denominator, which means if we move mass, we're going to have 1 over volume. So you have to start with the same step. Multiply both sides by volume, get yourself to the mass equation, and then you divide both sides by density. Alright, so you have volume equals mass over density. So use whichever way you prefer, whatever is easier for you to get through. If you're really strong with your algebra skills, I'd probably just rearrange equations. If your algebra skills are kind of weak, then maybe stick to the triangle method and just cover up the letter that you're trying to solve for to see whether or not they're next to each other and you should multiply, or if they're on top of each other and then you should divide. Okay? So, volume, I'm going to assume that we're okay here. Just recognize that volume is length times width times height. Alright, generally the longer side is length, height is how tall, and width is how far it goes back. Okay? But you just take your measurements on a solid object and multiply those three together. Okay? So, here's some densities of common substances. There's nothing in here that I would necessarily expect you to remember except possibly water. Because water is our 1.0 density when measuring in grams per centimeter cubed or grams per milliliter. Okay? So, just keep that in mind. But in problems, I'll give you the density of something other than water. Alright, so because density is an equation, you end up having to do math related to density. Alright, when you do it, and this is a way to, 1, make sure you show me work, 2, hopefully to prevent errors, alright, and 3, show your work in a meaningful way that's easy to interpret. So, here we have what I call SU. Alright? SU stands for equation, meaning you need to write out your equation with variables, alright? Not with numbers yet. Then, second step, you substitute in the numbers. Second S is essentially to solve, alright? So get it down to a single number. And then units is just a reminder to never forget your units. I am anal about them. I will mark you off for units all the time if you keep leaving them off. Okay? So, let's see what this looks like. Frank has an eraser. It has a mass of 3 grams and a volume of 1 centimeter cubed. What is its density? So, what I usually like to do is go through, underline the numbers. Alright? If I know, I'll sit there and give them letters for variables. Like 3 grams is mass. The 1 centimeter cubed is volume. Okay, and then I set up my equation. I want to find density, so it's D equals M over V. Okay, or if you prefer to see it clearly as a fraction, M over V. Next, you substitute in those numbers where they belong. Right? I see a mass, I see a volume, so I'm going to have D equals 3 grams over 1 centimeter cubed. All right, now S solve. I actually divide this stuff out. 3 divided by 1 is 3. So 3, and then units, if you want to rewrite it separately, you can do that. 3 grams per centimeter cubed. All right, or a lot of times what I'll do, because I really just use the U as a reminder to remember the units, is I will just write them in here, grams per centimeter cubed, and then just draw an arrow so that I know that I took care of the U. Okay? So let's try a few problems. Frank has a liquid. It has a mass of 9 grams and a volume of 3 milliliters. What is its density? So 9 grams, 3 milliliters. I want to find density. I know grams is mass. I know milliliters is volume. My equation is going to be density equals mass over volume. And then I'm going to substitute in the 9 grams for M and the 3 milliliters for V. If I solve that, density equals 3, and then just so that I don't forget my units, grams per milliliter. Okay? Alright, let's try another one. Mary has 5 milliliters of water and knows that the density of water is 1.0 grams per milliliter. What mass of water does she have? Alright, so this number I know is volume. This I know is density, and I want to find mass. So, when you're not starting from the main equation, I do prefer to at least see it. Oops. Right? For some of you guys, when you have to rearrange, actually writing it out correctly first helps with the rearrangement. All right? So we have density equals mass over volume, and I want to find mass, so I need to get mass by itself. So I multiply both sides by V, and that becomes mass equals density times volume. Now I can substitute in my numbers. Mass equals 1.0 grams milliliter times 5.0 milliliters. And when you multiply those together, since these milliliters are in the bottom and those milliliters are up top, those are going to cancel. All right? So that gives us 1 times 5, which is going to be 5. And to maintain our sig figs, we're going to leave the 0.0 in there. All right? And then since milliliters canceled out, our units are grams. Okay? So here's a couple more problems. All right? Everything in here is pretty much set up for not necessarily practicing sig figs, but remember, when we get into more problems or book problems, try to maintain your significant figures. All right? So try these. If you're watching this from home, obviously you won't have a neighbor, but try these. The first one should give you 2 grams per centimeter cubed. And then the second one should give you, let's see, we're solving for volume, which is going to look like mass over density. So 8 divided by 4 is going to be 2 milliliters. Okay. But now I want to talk about things in more of a conceptual sense. just so that you have a good feel for just general comparisons related to density. All right? So here's an example where we have two equal masses. Okay? Or sorry, two equal volumes. Equal volumes. So you can see that the cubes are the same size. Now, they don't have the same mass, all right? So the one with the greater mass means that there's more stuff in that little tiny cube than there is in the other one. So more mass means greater density. Okay? You can also think about it, if this number goes up, so does that number. All right. Conversely, let's consider equal masses but unequal volumes. So these two objects have the same mass. Okay? So say they're both 5 grams. One of them has more volume. So if you think about our equation, D equals m over v. Mass is staying the same, but volume's going up, which means we're dividing by a bigger number. Which means we have more space to spread the mass out in. That is going to decrease your density. Okay? So larger volume means smaller density. So if we can increase our volume, that's going to decrease our density. Okay? Then one last thing to kind of talk about is called specific gravity, or I'd like to say kind of more like floating, or whether or not something can float. Okay? Specific gravity is dependent on the liquid that you put the objects in. All right? Typically, we'll talk about this from water. And to know if something's going to float, right, it has to have a specific gravity or a density less than the liquid it's put in. Okay? So if you notice, ice and cork have densities less than 1, so they're floating. Whereas aluminum has a density of 2.7, and that's greater than water, so it sank. Okay? So, when dealing with liquids, it still works the same way. It's just the liquids will form layers. Okay? So it's not like they kind of are halfway in the liquid floating. It's actually, they'll stay on top of each other and form separate layers. So like, if this is water, it's a completely separate layer from the next one that might be, say, alcohol, which has less density. Okay? So, again, higher the density, the more likely it is to sink, or it'll go towards the bottom. Okay? So high density will be at the bottom, low density will be towards the top. So, look at this picture. It's not necessarily from your book, I just borrowed this PowerPoint. But let's think about which layer should have the highest density. Alright? So higher density, the lower it should be. So this is going to be our high. Okay? And which one should have the lowest density? Lower density means you can float, so you can sit on top of things. So this is going to be our low density. So let's label these. If, say, we knew each color had a specific density as listed. All right, what is our highest density? Hopefully you're saying the 10 grams per milliliter. So 10 grams per milliliter is going to go here. Which one's our lowest density? That's the 3 grams. I wrote that totally wrong. All right, so next one, where should 5 go, blue or red? It's our next lowest density, so it's going to go below the 3, but it still has to be above the 6. So 5 grams per milliliter and 6 grams per milliliter. Okay? So again, if you're not in class, you probably won't have a neighbor to try this with. But see if you can categorize these liquids as high, medium, and low density. All right, so where will the highest density be? Hopefully you're saying bottom, so that's going to be the syrup. And then which has the lowest density? Where would that be? Hopefully you're saying top, so that's the oil. And then which one has the middle density? Probably the one in the middle. So So that's going to be water. Okay, so after watching this, please make sure you have notes to bring to class, and please try the online quiz. But I'll see you in class.